So now next topic is about solution of standard types of first order partial differential equation. So the solution of standard types of first order partial differential equation is, so first, what is first order partial differential equation? Okay, so if there is a partial differential equation and it involves just p and q. What is p and q here? Dou z by dou x and dou z by dou y. So these two alone, if there is a particular differential equation that has these two things alone, it will be known as first order partial differential equation. And for this first order partial differential equation, we have a general form f of x comma y comma z comma p comma q is equal to 0. And if the equation of a type p comma q is equal to 0, there will be integral. You will see about what is singular integral in the upcoming slide. So there are many types of solutions in partial differential equations. Okay, the first one is complete integral. So what is complete integral is that if we obtain a solution, okay, in that particular solution, the number of arbitrary constant is equal to the number of independent variables. Okay, we have seen about independent variables, right? At the starting, and arbitrary constants is a and b. We have been seeing this arbitrary constant in the last two lectures, right? So we know what is arbitrary constant and independent variables. So if the number of arbitrary constant is equal to number of independent variables, then it is known as complete integral, or else we will say it as complete solution. What is particular integral is that if we in that complete integral solution, we'll give the values for particular values to that arbitrary constant a and b. It is known as particular integral. And what is singular integral is that in that complete integral, if we eliminate the arbitrary constants a and b, it is known as the singular integral. So what is the general integral is that if the solution contains many arbitrary functions like a, b, c, many arbitrary functions would be there, that solution is known as general integral. Okay, so if a solution, it has number of arbitrary constant is equal to number of independent variable, it is complete integral. In that same complete integral, if you give values for arbitrary constant a and b, that is known as particular integral. And if you are eliminating that arbitrary constant, it is singular integral. And if there are more than one arbitrary function in a particular solution, it is known as general integral. Okay, now we have to see on type 1. Okay, type 1 is the equation will be of the form f of p comma q is equal to 0. Okay, so what are the things you have to remember is that if there is a question like f of p comma q is equal to 0, so your solution will be in the form of z equal to ax plus by plus c. This will be the trial solution. If there is a question in the format of f of p comma q is equal to 0, what would be your trial solution? Z equal to ax plus by plus c. Okay, so in that, how you will find the final answer is, like, first you have to know the p and q. Okay, what is p? Nothing but dou z divided by dou x. You can name it as a. What is q? Dou z divided by dou y. You can name it as b. So automatically the question will become f of a comma b is equal to 0. Then the solution will become z equal to ax plus by plus c. Okay, now if from that f of a comma b is equal to 0, you should find the value of b. The value will be anything. Okay, if you find the value of b, then you will get any values. Let us name it as beta of a. Substitute that answer in the solution. You will get z equal to ax plus by plus c. In the place of b, you will substitute the value what you have find in b. We have given it as beta of a here. So if you find that value and substitute here, it would become the complete integral. Okay, this is how you find the complete integral values. Okay, you can see the example. It would be easy for you to understand. So here pq is equal to 1. It is of the form f of p comma q is equal to 0. So obviously the first one, you will find the complete integral. To find the complete integral, you should have the trial solution. What is the trial solution? Z is equal to ax plus by plus c. And you know that p is equal to a and q is equal to b. Substitute the value, you will get a b is equal to 1. So from that you have find the value of b. So keep b as left side and take other things to the right side. You will get b is equal to 1 by a. Substitute the value b is equal to 1 by a in the solution. Z equal to ax plus by plus c. You will get z equal to ax plus 1 by a y plus c. So this is how you will find the complete integral. One more example. what if it is p square plus q square is equal to 1? As usual, p is equal to a, q is equal to b, you will get a square plus b square is equal to 1. So b is equal to 1 minus b square is equal to 1 minus a square. For b, you will get p is equal to root of 1 minus a square. So substitute the value is in z equal to ax plus by plus c. You will get the complete integral. And what if the question is like this: p square plus q square is equal to npq. We know that p is equal to a and q is equal to b, and that solution is equal to z equal to ax plus by plus c. Substitute the values, you will get a square plus b square is equal to nab, and the equation forms like b square minus nab plus a square equal to 0. This is in the form of quadratic equation. If it is in the form of quadratic equation, how will you find the root values? The formula is minus b plus or minus root of b square minus 4ac divided by 2a. So substitute the values here and you will get the value b is equal to a by 2 into n plus or minus root of n square minus 4. Substitute the values here and you will get the complete integral. And fourth one, p plus q plus pq is equal to 0. We know that as usual a plus b plus ab is equal to 0. So from b plus ab, take b as a common n and take it outside. So b into 1 plus a plus a equal to 0, plus a goes to the right side, becomes minus a. So b is equal to minus a divided by 1 plus a. Substitute it here and you will get the complete. And you have a question here: a solution obtained from the complete integral by assigning the particular values. If you assign the particular values to the arbitrary constant, it will become particular integral. Okay, and p is equal to q, then the complete integral will be z is equal to x plus a into y plus b. And here 3 questions I have given on type f of p comma q is equal to 0. We can solve this and find the answers for this.